B2A Solutions is your trusted IT consulting company located in the heart of Europe. We design, build, and maintain scalable and user-friendly solutions tailored to your needs. Want to join a team that is shaping the future of the JavaScript ecosystem in Belgium? A team involved in the community by organizing events and contributing to open source? Join B2A Solutions now.
It is my pleasure to introduce another great female speaker, who is a senior full-stack developer at Ubik. Am I pronouncing this right? Yes. All right. She's going to spill the beans. See what I did there? She's going to spill the beans on the secret life of package managers. There's a mistake in here, I think. It says over 30 years of software development. That's not possible. You started in kindergarten?
No.
Wow, over 30 years. I repeat, 30 years of software development experience. That's very impressive. That's very impressive. Currently focused on JavaScript and its ecosystem, and always happy to share knowledge with other developers. Is Beyoncé ready? Here it comes, ladies and gentlemen. Tali Barak.
All my ladies, pop your backs with it.
Okay, so let me know if this sounds familiar to you. You run npm install, you go and get another coffee, also I understand you're not that much of coffee people, and you have your coffee in the kitchen, in your house, in your office, and then you come back, and hopefully it worked, and you have no idea what happened in between. If this is your case, so you're in the right place. My name is Tali Barak, as Claude said, and I work for Ubik, and let me tell you a bit about the secret life of package managers. And in order to do that, as we always do, let's do a bit of a time travel. So JavaScript started at 1995. I think it was May, by the way, 10 days in May. And it was meant to be this sort of a scripting language that is adding a bit of animation to your browser, maybe some drop-down, very small things, and like this one from 1996. And then it evolved over time, the millennium passed, and it started getting bigger and growing, and we had more sophisticated apps like Gmail in 2004 and Google Maps, and it started using JavaScript heavily. And then in 2009, this nice guy, which maybe some of you recognize, Ryan Dahl, came up with the idea that, look, it's a great engine. Why won't we actually use it also for building server-side? And he came up with the idea of Node. And Node grew, and when you write a backend server, you need a lot more. And one of the things you need is modularity. It's no longer just a small script that you put on your web page. And he came up with a model system that is called common.js. And the legend has it that it was actually, it was mentioned here that there was ES5, and before that there was ES3, and you probably wondered what happened to ES4. It was rejected. It never published. But one of the things that ES4 had is a module system that was named Server.js. So Ryan Dahl adopted it for Node.js and called it Common.js. And it started growing and started really hitting because it was fast, it was very easy comparing to the other alternatives you had at the time, and people start writing Node models more and more, very popular. And one of the people that wrote those Node models is this guy. Does anyone recognize? No? Well, you should. This is Isaac Schluter when he was young. And he understood something very critical. He said that if you want to increase speed, there are one of two things that you can do. Either you can push hard, or you can reduce friction. And this is physics. This is Newton's law, right? This is what you do. And he said if everyone is doing one, and everyone was pushing hard and writing more and more code, I will do the other one, and I will reduce friction. And the way to reduce this friction was to be able to share code easily between different applications. And he came up with the idea of NPM. And this is what NPM was initially, back in 2009, 2010. You would go and say require NPM, which was an external module, install, and you would put to a tarball. A tarball is like Linux zip file. And you had to know, where is this? Where somewhere in the internet, someone put a tarball with the code that you wanted. So it was okay as a starting point, but later on it realized that this is not enough, and he came up with this. He added a registry, the NPM registry, pretty much as we know it today, and he would say that you would put the packages in your NPM registry, and then people can find it easily, and they don't have to search the internet. It was smaller at the time, but they don't have to search the whole internet in order to find the packages. And in order to find those packages, you actually needed to add only 2 fields. You needed to add a new file called package.json. I assume most of you heard about it by now. And put 2 fields into it, a name and a version. And he would actually go into different repository and add and make a pull request with this file and these 2 fields. And he made a very bold decision at the time. He decided to use Semver. Today we look at it and it's almost obvious. Yeah, of course, everyone used Semver, but it was not that obvious back then. And he decided that NPM is only going to use Semver versions. And let's do a little detour here and talk a bit about what is Semver. So Semver stands for semantic versioning, and it's basically comprised of 3 numbers. The right one is called the least significant, you would say, is called a patch. And when you increase this one, it meant that you are introducing bug fixes. Okay, but it's only bug fixes. It should work well with your previous with the previous version if you worked with it. The next one is minor, and minor said we can introduce new functionality. And for those who don't know, in software, new functionality is actually a euphemism for new bugs, but that's what it is. But it should still work, right? It should be backward compatible. And then we have the major, the most significant one, which means, well, we might have broke something. It might not work that well with your version. And when you wanted to use a version in a package.json, you would specify what is the type of version that you want. Like, I want 391, but also introduce 2 more, another syntax, which is the tilde, which means I want any patch version after the version that I specified. So if I want 391, I might get 392, 393, or any other version. This is, by the way, the Lodash versions. Not that up to date, but they are. Or you could use the carré. And the carré means I can use any minor version after the version I specified. So if I would say carré 391, I would get 39123, but maybe also 310, 0, 1, or whatever version come after that. And remember that, because as Chekhov said, if in the first act you hang a pistol on the wall, then in the following one, it should be fired. So remember Semver. And let's go back to NPM. NPM is basically comprised of 3 things. One is the registries that we mentioned. This is where you store the versions, the different versions that you have. It has a search engine. This is the newer one, but there were previous versions where you could actually look for a package. Okay, so I want something that does this and that, or maybe a server, so you can look for it and find the right package that you want. I also assume that everyone in the audience is familiar with it. And it has the CLI, which you installed locally, and you used it in order to install your packages. And at the same time, around 2011, NPM became part of Node. So you would install Node. Until then, you would have to find NPM and install it separately. So, but around this time, you would install Node, and you would get NPM. And the love child of Node and NPM are the Node models folders that we all know very well. So how does it work? You have your project, and then you have an index.js, and you require foo. So you do npm install foo. It will add it to your package.json locally on your machine. It will create the node modules folder, or if it existed, and it will put foo in this node modules, right? Simple. But what about if foo package.json actually said that it needs Buzz? Oh, well, no problem. It will create another node modules, and it will install Buzz. But what if Buzz has a package.json that requires backs? No problem. We have node modules, and we have backs. It will install backs, and so on and so forth. Let's take this example to the extreme. What if you have foo that requires Buzz? It will install node modules and Buzz. But then if you had bar that also require Buzz, you would create another node modules under bar, and it will also install Buzz. So it looks okay, but almost. There were some problem with that. The first one, and this was a very popular slide a few years ago, and there's a good chance that most of you have seen it. Node modules became the heaviest objects in the universe, more than the sun, more than black hole, more than everything. And you would see that almost in every JavaScript conference. So the size of node modules became huge. Another problem was that it created circular dependencies. And you think this is very rare? It is not. It is more common than you think. So you have foo that is requiring a bar, that is requiring Buzz, that is requiring bucks, but then bucks requires bar, so it goes on and install Buzz and install bucks and so on forever and ever. So that was another problem that we had to deal with. This one is my favorite. It's a bit eccentric, I would say, but some of you may remember that there used to be an operating system that is called Windows 8. And apparently, in Windows 8, there was a limitation. The path name could only be 256 characters. So if you need to install this very deep nested directory structure, you would get up. It would hang at some point, and you could not access it, and this is real. I mean, I had this personally. You could not even delete it because Windows didn't know how to get there. And another problem, the last problem that is relevant here, is that we had a singletons problems. Sometimes we would put a package that we want, and a very popular example is debug. You would have it once, you would configure it to do what you want, but then another package would install another instance, and poof, all the configuration is gone. So we have those issues. What should we do? So they came up with this idea of deduping, meaning we can remove the duplicates. So if I have a project that foo is requiring bar and Buzz, and bar and bucks requires Buzz, let's move them to the level, to the highest level that they are common. In this case, it's a project, but it can be a lower level. And we will put it just once, remove it from the other places that it was. And then they said, well, why only for the duplicates and why moving it to the lower level? Let's take the whole tree and, did I pass that? Sorry. And the reason this worked is the way Node is searching for modules. So if it needed Buzz, it would start from where it is, and it would start going up the tree and finding where the package is located. So it doesn't find it under Barak, it doesn't find it under bar, it goes to the top-level node modules, and yeah, it's there, no problem, I can use it. And then they took it even one step further. We can take it and actually flatten the whole tree, so everything will be moved to the top level and put it there. So now we have a simpler tree, and we pretty much solve the issue that we have, right? We don't have duplicates, so it's no longer the huge size that it used to be. We have short path. Obviously, this problem was solved then. Windows 10 and other operating system doesn't have it, but still, it was solved. It is unidirectional, because if you only put the package once, you don't have the problem of circular. It is already there. We don't need to go ahead and reinstall it. And the uniqueness is also solved, right? Because you only install one instance of that package. So it looks pretty good. Life cannot be any better, don't you think? Well, here comes our gun. We have the versioning issue. This works well if we could support multiple versions, or if only we had one version. But what do we do when different packages actually require different versions? So in this case, like foo is requiring buzz carré 1, and bar is requiring buzz carré 1.1, and carré, a reminder, is a version bigger than the a minor compliant version, then no problem, we can move it, we will put whatever, maybe the version now is 1.3, it is there, it's all good. But what happened if we have foo requiring buzz at version 1 and bar requiring buzz at version 2? And those two versions are not compliant. And this is what NPM used to do. If you would install buzz 1 before buzz 2, it would move buzz 1 up the tree, and it will put the buzz 2 under the version. It still does pretty much the same today. So it would do that. But if you put buzz 2 after buzz 1, buzz 1 after buzz 2, it would put the buzz 2 at the top level, and the buzz 1 would be under it. And the problem with that is that it's unpredictable. You cannot guarantee that you and your colleagues or your CI or whatever will get the same structure of the tree, of the node modules tree. And we know this is a problem, because this is where bugs love to hide. What we get in reality is that our tree is actually determined by 3 different things. The first one is our package.json. What are we putting in our package.json? The second one is what exists at the moment of installation on the registry. And the third one is what actually exists in our current structure, in our local folder. And while 2 of those things are controlled by us, the NPM registry is not. You're doing something, you go to sleep, you wake up the next day to find out that there's a new version in NPM, because it gets new versions all the time, and you get a totally different result. And so they came up with a solution. We should do a snapshot. What we should do is actually take a snapshot of everything installed, store it, and keep it on our machine next to it. And it was initially called the package shrink wrap. Today we know it as package lock. And this avoids this problem that everyone can get a different tree structure. It is there, and we know how to save it. But there was still a hidden problem here. NPM install is actually playing 2 parts. It is used in order to install the existing packages that we have, But it also used the same command is used for adding new packages. So there is some discrepancy here that we are not really sure what will happen when we do npm install and add a new package. And some of the guys that didn't really like it were the guys in Facebook. So they decided to come up with their own package managers that we all know, which is Yarn. And Yarn did a few things that are different to NPM. The first thing is the log file. When Yarn was introduced back in 2016, I think it was, the log file was the default. It's not like you have to enable it as you did for NPM at the time. It is there, it is always there, and it keeps your node modules folder sane. Also, they separated the install from the add. So if you wanted to add a new package, you would specify and say it explicitly, Yarn add this package. And if you do just Yarn install or Yarn, it will just go and install what you have. So it makes it smaller. So it makes it much more explicit for people to use. And the last thing is speed. Because all of this recalculation of the tree and because of other improvements that they did, like caching and so on, they made it a lot faster. And if anyone here remember NPM 2 or NPM 3 and 4, they were really, really slow. And cool, now we have competition. It's no longer NPM alone, it is there. And this is actually drove NPM to bring a lot of improvement as well. In versions 5 and 6, they really improved it, and that's because of the Yarn competition. We still have some problems. It's not that it is that great. So one example is, let's say my foo needs a Buzz 1.1, and at some point of time, it was moved up, it was flattened to the root with, let's say, version 1.05. which was the version at the time. If now I add bar and I say I want 1.06 as a patch version, which it would go and simply refresh your existing one because it is compliant. It knows that it's compliant. We don't have an issue here. But what if we had 1.1, it was flattened to 1.05 at the time, but then bar needs 1.0. In this case, in this case, you might get a version that is somehow wrong, and it won't actually refresh it. It would stay on the same version without upgrading it. And this is why, in so many cases, when you do npm install and you have some problems, you're going to Stack Overflow, and this is what you will find there. Just remove your node module, just remove your package lock or yarn lock, and do npm install all over, because this will cause npm or yarn to recalculate and refresh. By the way, with NPM 7 and 8 now, it is better. It knows how to recalculate like an optimal tree for the time, so it is less needed. And those of you who are on NPM 7 and up probably realize that you don't need to do that so often. Another thing that Yarn introduced and solves our problems is their resolution, and this still doesn't exist in NPM. You know, you say it doesn't exist, and then you wake up in the morning and you check something and you realize, oh, they just introduced it. So not to the best of my knowledge, but who knows? And the problem is that sometimes you want to control the version that are deeper in the tree. We only have a control over the top level. This is where our package.json is defined. But if you want to control what is installed, because let's say 3.1 has a bug and you want to make sure that you install 3.0, that you know it works, but the package.json for bar was already changed, you can specify that with Yarn and say, go ahead and in the bar under foo, do install 3.00, even so its package.json is saying something different. So that's another thing that Yarn is doing in order to help you control on that. But let's go back to the core issue? What is the core problem? Why do we get all these problems? And the reason for that is simple. Our directory structure, no matter what operating system, is a tree structure. Okay, so each folder actually has one parent, which is its parent folder, and so on. But our packages are actually in the format of a graph. So anything can point to any version on the graph. It's not like well organized in this term. And a nice solution for this problem came up with PNPM, beside a lot of other optimization that they did about the installation and so on. So this is what PNPM is actually saying. This is how I solve the problem. So I still keep the old trick structure, you know, the one that we saw at the beginning, where everything is defined under everything. But in order to avoid the problems that we mentioned, it only keeps in its own cache only a single version of each of the packages. So the node modules that we have in our project is not really saving all the files. What it does instead is pointing, using a symlink, to the cache and using the file there. So node module is actually thinking, oh, cool, I go to foo, I go to buzz, directly I know where to find it. But in fact, it will be symlinked and go into the cache. And this makes PNPM a lot faster and a lot smaller, obviously, because you don't keep multiple copies. In fact, it does it even better with storing just the content of the file, and it is there. Another interesting approach was taken by Yarn 2, now to some extent Yarn 3, which is the Berry code name. They decided they have their plug and play. And what does the plug and play say? The plug and play is actually saying, look, I'm Yarn. I am the package managers. I know what is a package that you want to get every time you ask for a package. So don't go to the directory structure. Instead, when you do a require or an import and you need a package, ask me what is the right version that I need to bring you, and I will get you this version. So what they did is actually they patched the node require with their plug and play. So now every time it is a require, it doesn't go directly to the file system. It goes to Yarn. And Yarn, according to all the knowledge it has about the packages, will point it to the right folder. And this is an interesting, it's cool, it's an interesting idea, but it can become a bit complicated if you're trying to migrate. So yes, this is a bit of a history of NPM. Beside everything else, we can see, we know these graphs. NPM has grown like no other package manager. Semver is now a de facto standard almost on all new package managers. And while I was working on this talk, I was going through the history of NPM, all the old files. Luckily, we are very lucky to have like the whole history written for us within GitHub. And I came up with some paragraphs that Isaac Schluter has written over 10 years ago. And it's amazing to see how much vision he had and how much he knew what is going to happen. So let me play that for you.
This thing was a baby yet. But these kids grow up before you know it. Pretty soon, you'll all be tapping out your pipe on the front porch, saying in your withered old man voice, I remember back before the war with the machines, when that NPM thing couldn't even install itself, and didn't know what a version was. We used promises for everything, and the global object was called Node. Movies were a nickel, and we downloaded them from the microtorrents, and soda pop had the corn syrup of the highest fructose imaginable. You young'uns don't know how good you got it.
So if any of you is new to this ecosystem and you don't realize how painful it was, here it is, and I hope it was good. It was learning. Thank you so much. My contact details are here.
B2A Solutions is your trusted IT consulting company located in the heart of Europe. We design, build, and maintain scalable and user-friendly solutions tailored to your needs. Want to join a team that is shaping the future of the JavaScript ecosystem in Belgium? A team involved in the community by organizing events and contributing to open source? Join B2A Solutions now.